Hi everyone. So, as part of the data structure series for beginners, in the previous video, I have discussed what are the things you need to prepare, how to start data structure if you are a completely beginner. Okay, so please check out that video first because that video will help you what is data structure, how to start, what are the things you need to focus on. So today, as part of the series, I will be explaining you the basic thing about the array and the linked list. And in the next videos, I will be explaining about the tree and the graph and the stack and queue. Everything we will cover one by one. So I will keep the level as the for the beginners that you do not know anything about the data structure. So this video is for them as well. And if you are expert, then you can skip the video and you can check my other videos where I have covered the lot of famous interview questions with the lot of approaches. I have discussed those questions. So let's jump to the today part, which is nothing but what is array, what is linked list, what are the basic operations in case of array, and what are the basic operations in case of linked list, and the difference between these two data structure. All right. So in the previous video, I discussed that these two are part of the linear data structure. What linear data structure means? Linear means they will be stored in the memory in the one directional form, let's say. Okay. So when we talk about the non-linear, then you will see the tree and graph, hash table, they will be part of the non-linear data structure. All right. Now let me jump to the what is array. Okay, first of all, we'll discuss what is array and what are the basic operations in the array. So basic operations will be nothing but insert, delete, update, and the search. All right. So we will discuss about these four operations in some time. So now let us understand what is array. Now, array is nothing but a data structure which will store data of same type. Okay. Data of same type means whether it will store all the data of whose type is same. Let's say here in this example, you can see we are storing 100, 101 up to 104. These all are integer numbers, right? So you can see the first line here, int values of 5. What it means? Int is the data type of the value which we will store. All right. Now, values is the name of the array, and 5 is the size of the array that we can store 5 elements in this array. Understood? And array is actually zero-based index. It means that first element will be stored at the zeroth index, last element will be stored at the size -1. So 5 minus 1 is 4. So if you want to access the first element of the array, what you need to do? You need to do values of 0. All right, perfect. Now we will jump to the basic operations of the array. Now I have written a code for you guys so that it will be easy for you to understand how things are actually working. Now let me jump to the Eclipse and I will explain you. Okay, so I have written the code for array. Now, first of all, okay, in my previous video, I have taken example for the age. Okay, so we want to store age of the student. Now this is the one array. Now here what we are doing, this is nothing but the declaration part. Now, okay, let me tell you one more thing. So when we talk about the declaration and all, so it will vary from language to language. If you are in the C, if you're writing your code in the C, things will be slightly changed, but rest all and concept will be same. So here I am explaining you the code in the Java language. And if you will understand this thing, you can write the code in your own language like C, C++, Python, whatever you like. All right. So this line denotes so first line is nothing but the declaration and assigning. So both the things we are doing in one go. So int denotes the type of the data which we are going to store. So since age is the numbers, so we will use the type as the integer, and here you can see it has 8 elements. All right. Now here I have written how to print this array. So for printing the array, we need to run a loop. Okay. Now for printing, let me show you the code. This is our array, and we want to print all the student age. So just run a loop. The first index will be 0, as we have discussed already. Last will be length minus 1. So here you can see we have applied less than condition. So the loop will run from 0 to length minus 1, and we are just printing the age of I. So this is how we access the elements of the array. All right. I hope it is clear. Once we are able to access the elements of the array, now first thing I want to talk about insertion in case of array. So let's say you want to insert one new element in the last. All right. What you will do? Tell me. So here you can see this age will have size as 8. Now you want to insert one more element. Okay. So what you need to do, we cannot insert in the same array because we have already reached to the maximum size. So we need to declare one more array whose length will be current age length plus 1. So here length will be nothing but age dot length plus 1, and we will declare one more array. So whose size will be the new length. All right. Now in the last position, we want to insert 16. So here we are doing that. But before doing that, I need to bring the data from age array to age 1 array. So this loop will copy the data from first array to the new array. All right. Now, don't you think what we are doing for insertion, we are running a loop. We are redeclaring one new array whose size will be previous array length plus 1, and then we are putting the new element. So the time complexity, if we talk about time complexity, what is time complexity? Time complexity is how much time this operation took. So here we are running one loop. So time complexity will be nothing but O of n. All right, where n is the size of the array. Perfect. Now, after inserting this one, I just printed the array one more time just to show you that we have inserted it. All right. So let me just run the code. So here, this is the array. This is the first array. Here I have inserted 16 in the last, you can see, right? So do not worry about these things. We will go through these also. But this is the first thing I wanted to show you. After insertion, you can see 16 is present in the array in the last, right? Now we will jump to the second operation, which was delete. Let's say you want to delete 12. So from this array, you want to delete 12. All right, here, what you will do? You will declare one new array whose length will be length minus 1. Because we are deleting one array element. So here, if you found, we'll run a loop again. If you found out that, hey, your current element is 12, do not insert it into the new array, else just insert the array element into the new array, and we'll just print it out. So you can see output of this line number 38 is nothing but this one. Here you can see after 10 we have 11. After 11 we are directly getting 9. It means we have deleted 12. Understood? So what about time complexity? Here also we are running one loop. So time complexity will also be nothing but O of n, because we are running a loop to delete the element. So here, why we are creating new array? Why we are running a loop? Because we need to shift the element. Let's say you want to delete 12. Okay. So what you will do? If you will update this 12 with 0, then we are not actually deleting it, right? So to delete it, after deleting, we need to shift all the right side element towards left side. So 9 will come in the place of 12, 8 will come in the place of 9, and so on. So that's why we need to run a loop. All right. I hope it is clear. Now, third one is how to update element in the array. Let's say you want to update the third element to 40. So third element means I told you array are 0 based index. So third element will be stored at the second index. So what you need to do, just do as 2 of 2, where 2 is this 2 is the index of the array element, and update it with the 40. Just print it out. You will see, hey, see what we have done here. In this one, you can see we have updated third element, which was 9 previously. Now it is 40, right? So here we are not running a loop. That's why we can say in case of array, update operation is constant time. It will take constant time. So time complexity for update is nothing but the O of 1, right? Now you want to search some element into the array. We have this element as of now, right? In this array element, you want to search one key. Let's say key is 5. Okay, so we have 5 here. What you need to do, you need to run a loop from the first index. And every time you will compare, hey, are you 5? No, move forward. Are you 5? Move forward. And once you got 5, just print it out. So here we can see we are running a loop and we are getting the output as 5 is present in the array. All right. So we got the output and we can see that we are running one more loop again. So in case of array, insertion, deletion, search, all three took of n time, and update took only constant time. Here you can see. I hope these were the basic operations in case of array. All right. Now we will jump to our presentation part and we will move forward. So we have discussed insertion, deletion, update, and the search, and how much time each one of these will take, right? Now let us jump to the linked list part. So I think you are clear with the array, how to declare the array, how to perform all the basic operations in case of array. Now we will jump to the linked list now. So we will again solve all the basic operations in case of linked list also. Now what is linked list? Linked list is also one of the linear data structure, but here how we store the data, that will vary from array. So let me just tell you the difference first of all right? So you can see this example here. In the array, what I told you, so we will declare first element will be at the first index, second element will be at the second index, and so on. And in case of array, memory allocation, okay, this part is very important. Okay, please please focus on this part. Now here what we are doing, in case of array, memory allocation is contiguous. It means once we will store the first element at, let's say, this particular memory address 100. Okay, now next element will be attached to it. That means that will be contiguous. So here you can see array we are storing the integer will take 4 byte. All right, so next memory address will be 100 plus 4, so 104. So 33 should be present at the 104. Next element should be present at the 104 plus 4, which should be at the 108, and so on. But in case of linked list, we can store elements at the random positions. So it is not necessary that linked list should be stored in the contiguous. It can be contiguous, it cannot be contiguous. That is the difference I wanted to show you. Okay, now let us jump to the linked list. Now in case of linked list, so what we have one node. Okay, first of all, for every element we will keep one node. What this node will contain, so here let's talk about this first node. So here there are two parts. Every node will have two parts. One is the data, second is your pointer. So pointer is nothing but pointer will point to the next element in the linked list. So here let's say we have data like 25, 32, 58, and 63, right? So the first node will have 25 and pointer. This pointer will point to the second element, which is 32. And this 102 is nothing but the address of 32 in the memory. So this pointer will have the address of the second element. Here, the second element will have the address of the third element, and it will have address of the fourth element, which is nothing but 108. And last element will always point to the null. Null means that is the end of the linked list. And now you will say, hey, how to traverse this thing? So for traversing, what we need to have is we just need to have the address of the first node. Why? Because if we have the address of the first node, from first node, I can go to the second node with the help of this pointer. From second, I can go to the third. So in case of linked list, you just need one thing, which is the address of the first node. So let's say we will call it as head node. Head means the head of the linked list. All right. So this is all about the linked list, how we declare the linked list. Everything I will explain you in the coding part. So we will jump to the coding and we will explain you what are the insert operation in the linked list, how to delete, how to update, how to search. Do not worry about those things. So let us quickly jump to the coding part. Let me create one new class, which will be, let's say, linked list. Okay, just try to understand, guys. If you will understand these basic thing in the data structure, you will be master in some time. So first of all, I told you linked list has node. Okay, so for node, and node will have two things. Okay, you can see here node will have data and one is the pointer. All right, so here I will declare one class which will be, let's say, node. Okay, now what this node will have, let me make it static. So these are the Java code I'm writing. You can write the code in any language, whichever you want. So here, the one thing we have, every node will have data, right? Second thing, every node will have the pointer to the next node. Will point to the next node. So let's say we can give the name as pointer. Perfect. Now I will define one constructor here. Constructor will take just the data. All right. So I will say this dot data will be data, and this dot pointer will be nothing but null by default. All right. Now this is the simple declaration for a node in case of linked list. Now what I want to declare this first node whose value is 25. So I told you the first node of the linked list. First node of linked list is nothing but head node. So what you need to do, just define the value as 25. All right. So now our linked list has one node whose value is 25. All right. Now there is no second element as of now. Now you want to declare the second element. So what you will do, head node dot pointer, because pointer will point to the second element of the linked list. So you want to store how much? 32. So now your linked list has two elements. One is 25, second is 32. Now how to store the third one? So for third one, what you need to do, head dot pointer is second node, head dot pointer is nothing but the third node. So we can simply declare it and it will be nothing but 58. And now let us jump to the fourth one. Let us jump to the fourth one. So fourth one will be nothing but new node, and fourth one has 63. So now our linked list has four elements. First one is 25, second one is 32, and third one is 58, and fourth one is 63. So this is the declaration part. Now I just want to print the linked list. So how to print it? So let us define one method, which is nothing but the print linked list, and we just need to pass the head node. All right. Let us write down the code for printing the linked list. So let's say we want to print linked list, and we are taking one head node as the parameter. What you will do, you will run a loop. Okay. Let's say you will say, hey, current node, which is starting node. Okay, while current is not null. Okay, it means we didn't reach to the end of the list yet. What you need to do, you just need to print out, just print your head dot data, right? Because head node, every node, okay, so not head, it will be current actually. So your current node will have data. Just print it out, and let me put some space in between so that you will see the difference. Let us run it. Okay, so we should get 25. Next will be 30. Oh, here, sorry. See why we reach to the infinite loop here, because we are not updating the current will always point to the head, and loop will keep running, keep running, right? So you need to update here current dot pointer, right? So this will move your current to the second node, then third node, and so on. Now let us run it. So you can see we have here two. Okay, yeah, let me run now. So you can see we are getting 25, 32, 58, and 63. So we got these four elements, 25, 32, and up to 63. Understood? This is the how we are printing the linked list. Now we will discuss about, let's say we want to insert new element. Okay, let's say you want to insert 40. Okay, insert 40 in the linked list. Right? Now this is very important. Here, in case of linked list, where you want to insert 40, which is very important. So there can be three different possibilities. Okay, one, insert 40 at the start of the linked list. It can be possible, right? The start of the linked list. Second, insert 40 at the end of the list, end of the linked list, right? So we can insert anywhere. It depends on the question requirement. We can insert 40 in between somewhere. Insert 40 in between somewhere, right? Now, so time complexity for each one of these insert operation will vary. So let's say you want to insert 40 at the beginning. Okay, let us take one thing. So I will declare one method called, let's say, insert at beginning, at its start. All right. So just pass the 40, and you need to always pass the head node. Okay. So in this linked list, I want to insert 40 at the start. All right. And it should give us the new list. Perfect. Then after that, we will just print the new list. So after that, we will just print the new list. So let us jump to the insert at the start method. How we will insert in the beginning. So public static void and insert at start. All right. So we have a node and the data which we want to insert. Perfect. Now, what is this insertion logic actually? Okay, let us understand that part. So, okay, we are not returning. That's why we were getting some error. Yeah, perfect. Should be fine now. Public static node. Okay, there is no return type. That's why we are getting the error now. Fine. All right. Let me explain you with the help of one diagram. So this is the linked list we have 25, 32, 58, and 63. Our head is pointing to the first node of the linked list. Now you want to start 40 in the beginning. What you will do? So let me just try to explain you guys. So I want to insert one new node. Okay, so new node, what it will have? It will have 40 as the value, right? So till this point we are fine. Now our new node will also have a pointer which will point to some node. Now what I want to, this should be head now, because this should be starting node. So if you will make this node as the head node now, all right. So this is our, let's say, new head. Okay. Now perfect. This is our new head. Okay. Now this should point to the 25, because that is the, now 25 become your second node. So this pointer. This pointer should point to this one now. Understood? Let me just remove this head because this is no longer head now. All right. This is no longer head node now. All right. So our head now became this 40 node. So two things you need to do. What is first thing? First thing is point 40 to the head node. Okay. So new node. Okay. 40 is nothing but the new node, right? So new node will point to the head first of all, right? Because previously head was 25, right? So new node will just point to the 25. Second thing is you just need to update your head node to the new node, right? Which is nothing but 40, right? Which is nothing but 40. I hope these two steps we need to do and we are good to go, right? Let us jump to the coding part. What I was saying, we will take two things we'll do. First thing is we'll just declare one new node, which we want to insert. So how to create new node? It's very simple, you have seen. So we have created new node. Now what you need to do, you need to point new node dot pointer to our current head, right? And update the head to the new node. Understood? Clear, right? Just return the head and we will just print out. So now our output should be 40, 25, 32, 58, and 63. Let me just give one extra line here just to see the difference. All right, so this will just give the space in between the previous print and the new printed. Let us run it. So you can see 40 came in the beginning and the rest everything is same. So we have inserted the node 40 at the starting of the linked list. Understood? So this is how we have inserted. And did you see one thing? Here we are not running a loop. So time complexity, very important, okay? Time complexity for this one is nothing but the constant. Is nothing but the constant. All right. Now there can be two more use cases. We can insert the 40 in the last. We can insert the 40 in between somewhere. So when you want to insert 40 in the last, let us jump to the diagram. Okay. Let's say in this example, we want to insert 40 in the last. So here, first of all, we need to traverse from the first node up to last node. Once we reach to the last node, so last node pointer will point to the new node now. So what I'm saying is, so this will point to the 40 now. All right. And this 40 next will be null only. By default, it will be null. So you just need to traverse the linked list. And once you reach to the last node, just last node pointer will point to the new node and new node next will be null. Rest everything will be same. So let me write down the code for this also. Let's say I want to insert 70 at the end of the list, at the end of the linked list. All right, so how to do that? I will declare one method which is nothing but insert at end, and I want to insert 70. So I will declare one method public static node insert at end. Right, it will also take one head. Oh, we need to pass head node because without head node we cannot traverse the linked list. So head and the data which we want to insert. Now first thing you need to do is just declare the new node whose value is nothing but the 70. So it will be new node and the data. All right, now we need to traverse the linked list up to the last. So what you need to do, while head is not equals to null, first thing, while current is not equals to null. Okay, current dot pointer. Okay, so current dot pointer is not equals to null. Then we will keep moving the current. So we will keep moving the current, and this way we will reach to the last. So after this loop, okay, current will point to the last node. Will point to the last node of the linked list. Right. Now what I told you, there were two steps I told you. So last node next will be new node. All right. So you need to do current dot pointer will be nothing but new node, right? And we are done. New node next will always be null, right? Simply just return the our head again. So after this insert 70, let us print it out again. So I will. So now what output we should get? After 63, we should get 70 as well. Let us run it. So you can see after 63, we are getting 70. All right. I hope it is clear to you. Now, whenever you want to insert in between somewhere, what you need to, we need to mention some condition. Hey, after 32, I want to insert, right? Oh, so before going to that, I want to discuss the time complexity of this part. Since we are running a loop, we are going to the end of the linked list. So we are traversing the linked list. So the time complexity will be nothing but O of n, where n is the length of the linked list, right? Understood? So insertion at the starting was constant, and insertion at the end is nothing but is taking the O of n time. Now, when you want to insert in between, let's say after 32, all right, you need to run a loop to reach to 32. So in the worst case, this can also lead to the O of n time. So I would suggest, I would request you guys, please write down the code. In that code, what you need to write down is insert, let's say 75 after 32. How you will write down the code, just think about it and you will learn a lot if you write the code by your own. So we are done with the insertion part, right? Now let us jump to the deletion part. Okay, now again we can have lot of things here. So for deletion, let's say you want to delete, okay, let's say you want to delete 58. Delete 58. What you need to do, first of all, you will reach to the 58, then you will delete it. Now for deletion, let me explain you with the help of diagram. So here, let's say you want to delete 58. All right, our head is pointing to the 40. Now just start traversing from 40. You will reach to 25. You will reach to 32. Then once you reach to 58, all right, you just need to keep a previous. You need to store previous pointer somewhere. So why we need to store previous pointer is, if you want to delete 58, so what we will do is simply previous node, instead of pointing to 58, it will point to the 58's next pointer. So once 32 will point to 63, and this node will become garbage and it will be collected by the memory, and we have deleted the 58. So the steps are very easy. You need to keep previous value. Okay, you need to keep previous value, and once you reach to the 58, okay, you reach to the 58, just do previous dot next will be nothing but your 58 dot next, right? And we are good to go now. 58 dot next. So this is fine. Now let me write down the code. Here I want to delete 58. So delete node. You just need to pass the head and the 58 which you want to delete. So let me write down the code. Public static node and delete node. Delete node, and we will pass the head node here, and we will pass the data which we want to delete. What I told you, we will run a loop until we reach to the 58. Okay, so current will be nothing but here. Now what you need to do, current not equals to null, and current dot data should not be equals to the data. All right, here we will keep one previous pointer also. So for previous, let me take one variable which will be null in the starting. Now your previous will be point to the current node, and your current will point to the current dot next, which is nothing but the pointer. Understood? Now here what you need to do, simply just do previous dot pointer. Okay, previous dot pointer will be nothing but current dot pointer, and just return the head of the linked list. All right, here what you want to do, you just want to print the linked list after that. So this is the head. Okay, head is already declared, so I will just do this thing. For printing, I will call this method. Now why we are getting error? Once again, typing mistake. So yeah, we are good to go now. Right. So here we have deleted 58. Let us run the code, and we after 32 we should get 63. So you can see after 32 we got 63. It means 58 is deleted now. So let us talk about time complexity. Here we are traversing the linked list. Whenever we are traversing the linked list, okay, so just keep one thing in mind, that the time complexity will be nothing but O of n in that case. All right. Now, third operation was nothing but how to update, right? So third operation is actually nothing but the update, and fourth is nothing but the search. So we have already discussed about search also. Here so we are finding the element which we want to delete. So we need to traverse the linked list. Once we find the data, it means we are doing the search operation also. So for search also we are clear. For search, time complexity will also be of n, because we need to traverse the linked list. Now search is done, insert is done, delete is done. Now let's say you want to update some node value. Okay, so how to do that? Let's say you want to update okay 32 to some new value, let's say 40. Okay, so yeah, we want to update from 32 to the 42. How to do that? So first of all, we will reach to the 32. Once we reach to the 32, just update the data of that node to the 42. So update node to the new value. We need to pass the new value, and we also need to pass which node value we want to update. So 32, I want to update to the 42. Now let me just copy the code, because I wanted to save your time. So here it will be nothing but the update node. Here we have previous value. Here we have the new value. All right. So this is the previous. Once we reach to the previous, okay, no need of previous pointer here. No need of previous pointer here. So once we reach to the current, then current dot data will be nothing but the new value. All right. So we have just updated the previous value with the new value here. Now let me just print the linked list just to make sure that we have written the code properly. Now here what we should get, instead of 32, we should get. So you can see instead of 32, we got 42. All right. Third element you can check. So update operation also we have done. In the update also we are running one loop. So time complexity will be nothing but of n, where n is the length of the linked list. So I hope everything is clear so far. We have discussed insert, delete operation, update also, and search is nothing but we are finding the key. So insert, if you will insert at the beginning, it will be constant time, else it will be of n. Delete, if you want to delete the first node, it will be constant, else it will take of n time. And same for the update and the search. All right. Now let me explain you the difference between the array and the linked list. All right, because we have discussed so far, we have discussed basic operations in case of array, and in case of linked list, in both, right? Now what we want to understand the difference of these two. Yeah. So first thing, in case of array, an array is a collection of elements of a similar type, because we have seen we have declared one integer array, or we can declare one string array, we can declare one boolean array. So it is nothing but a collection of elements of similar data type. But linked list, what is the so what is linked list? Now linked list is a collection of objects, also known as node, where each node will have two parts. One is the data, one is the pointer to the next node, right? Now how elements are stored in case of array and in case of linked list. So those things we have already discussed. In case of array, okay, in case of array, we have seen that elements are stored in contiguous memory. But in case of linked list, elements can be stored randomly. So here you can see after 20, 30, 40, 65, and 81 came. But in case of linked list, here you can see first node is 20, second is 33, then 14, then we are having 65 as some different location, then 65 is pointing to the some previous location, yeah, right? Previous memory location. So in case of linked list, every node can be at the different positions. Understood? So let me show you one more example. Here you can see, in case of array, if all the elements of the array will be contiguous, you can see there is no gap in between the elements. But here you can see every node, every red color node denotes one element of the linked list. And here you can see every node is at a different memory location. That is the power of linked list, right? Because in linked list, we can put every node anywhere, and we just need to have address of the next node so that we can traverse the data. All right, perfect. Now we are clear about the memory allocation part in case of array and in case of linked list. Let us jump to the some other difference between these two. So we have seen whenever we want to read one element, it will be simply constant time, right? In case of array, because we can directly access the element based on the index. Let's say you want to access fifth element. What you will do? You will get array of 4, because array of 4 will give you fifth element. So accessing one element is nothing but constant in case of array. But in case of linked list, if you want to access fifth element, you need to traverse from starting to the fifth element, then only you will get the fifth element. Now we have seen insert element at the beginning, at the end, in between somewhere. So you can see time for each one of these operations. Now, which one is easy to use? So you can see array is very easy to use. But linked list, in case of linked list, the program is more prone to errors, like we have seen segmentation fault, memory leak, and a lot of care needs to be taken. For example, when I was writing the traversing code, okay, this code up. So here you have seen I missed this condition. I missed this particular line. So we ran to the infinite loop, right? So in case of linked list, when you are writing the code, you need to take care of a lot of things like segmentation fault, runtime error, memory leakage can also be there. So you need to be more focused while writing the code in case of linked list. But when we talk about the array, so it is very easy to write the code in case of array. Now, when we talk about size, in array, we always declare the size at the time of declaration itself. That we cannot change later point. If you want to increase the size, you have seen in the code, we were taking one new array with the size length plus 1, right? But in case of linked list, there is no defined size at the beginning, so whenever you will get new node, you can insert whenever you want, in the starting, in between, in the end. So linked lists are dynamic in size. Now memory allocation, in case of array, since we are declaring size at the declaration phase only, so memory will be allocated at the compile time. But in case of linked list, memory will be allocated in the runtime, right? Now you will see, hey, what are the applications of the linked list in the means where you will use the linked list. So there are few important points I have written here. First is linked list we can use to implement stack, queue, and tree. Okay. Second is linked list we can also use to implement graph. In the graph, you can see there were two kind of representation of the graph. One is matrix based, one is adjacency list based. So in case of adjacency list, we always use linked list. All right. Now linked list can be used to implement hash table as well, because in case of hash table, each bucket will be a linked list only. All right. So this is all about the array versus linked list. Now I have discussed basic operations like insert, delete, update. What are the differences? So what are the difference between these two? So I hope it is clear to you. If you feel anything is not clear out of these two basic part, okay, let me know. I will be happy to clear your doubts in the next video. In the next video, we will talk about the basics of the stack and queue. Then we'll talk about tree, then graph. So once we will be done with the basic part, we will solve more questions on these topics so that you will be expert in some time. All right. If you like my content, please like, share, subscribe. Thank you, everyone.